Hi, we're going to talk about measures of position, and we're going to hit up box and whisker plots, what other fractiles are, and how do we interpret the z-score. So with fractiles, it's dividing the data into equal parts. So with quartiles, we're dividing it into equal quarters, and we symbolize it as Q1, Q2, Q3, and keep in mind that Q2 is our median. When you have a word problem involving find the first, second, and third quartiles, we got to put all that data in order from least to greatest. The overall median becomes your Q2. You're then going to not include it when you split the data into two groups. So first set, or the lower half median is 26, the upper half median becomes 35, and then we symbolize that as Q1 and Q3. We could say that in about 1/4 of the large urban areas, auto commuters waste 26 gallons of fuel or less, and so on and so forth. So let's go to tuition costs. Let's use technology in order to do this. You have to hit your stat button, then edit your first list, put your data entries. You got to make sure that you have all 25. Then you're going to hit stat, go over to calculate, and we're going to do 1 var stats. And you're going to find that Q1, Q2, and Q3 turn out to be the following numbers. By scrolling down and identifying, starting with the minimum to the maximum, what the quartiles break down into. To make sense of it, we could say about 1/2 of these colleges charge $55,000 or less. Moving to the next topic, interquartile range. It is going to be the measure of the third quartile to the first quartile. Why we like finding it is it helps us try to figure out mathematically if we have an outlier within our data or not. The way we do that is after you find the interquartile, you're going to multiply the interquartile by 1.5. Then you're going to subtract and add that amount to your first quartile number, your third quartile number, respectively. And if you see any values outside of those boundaries, those are your outliers. So let's recall whenever we were doing college tuitions that first quartile and third quartile are the following. We find their difference, which is 11.5. Then we multiply that difference times 1.5, figuring 17.25. We find the very bare minimum of the minimum and maximum before you can determine an outlier. And we find out that in the original data, $19,000 is not common for liberal arts colleges. And so we state that. Using the numbers, we're going to graphically show a box and whisker plot. It goes from the minimum entry to the maximum entry and involve each quartile. So after we find the 5 numbers, what we don't see in our picture is that we're going to make sure that we construct a horizontal scale spanning the overall range of the data, and that's what we don't see in this picture. Let's go straight to an example. In the last problem, dealing with the college tuitions, we had the following 5 numbers. When we draw a box and whisker plot, we're going to ensure that we have a horizontal scale. We're going to determine a scale to show how big of a gap. You notice now that 19 is definitely an outlier, and that most of our college tuition rates are between $47,000 and $58.5 thousand of dollars. We just discussed quartiles, but there's also deciles and percentiles. Percentiles are more common within the real world in relation to birth weight or birth length, SAT, ACT scores, and so on. So this next example, we're seeing an ogive, and what test score represents the 90th percentile is the question. As we look at the 90th percentile, we see that the score that represents it is about 1350. What's important is, what does this mean? It means that 90% of the students had an SAT score of 1350 or less. It's that or less piece we've got to include in our explanations. If we need to find a percentile of a particular data entry, it's count the number of data entries less than what you're concentrating on divided by the total number of data entries, your sample size, and multiply that by 100, round to the nearest whole number. Let's use 57 as an example from the tuition example. Like, what would be that percentile? So if I look at how many data values were less than 57, there's 15 of them, and then divided by the total number of data entries, which is 25, multiply that by 100, we're looking at 60. This is the 60th percentile. So 60% of liberal arts colleges cost $57,000 or less. So let's say you wanted to find the number of standard deviations away that a data value falls from the mean. You're going to take the data value minus the mean and divide by the standard deviation. We're going to make sure that if we're putting this in our calculator all at one time, you're going to have parentheses around the data value minus the mean, then you divide by the standard deviation. Pause the video to read the following. We're going to find the standard deviation of each of these cars, the 62 miles per hour car, the 47 miles per hour car, the 56 miles per hour car. And then we're going to find maybe compare the standard deviations after that. Using the formula, taking the data value minus the mean divided by standard deviation, we find that the person who was driving 62 miles per hour is the following, 47 miles per hour, 56 miles per hour. Here's what I do know, is that the person driving 47 miles per hour, it is more unusual on this particular highway than the others, but a z-score is the number of standard deviations away from the mean a particular data value is. So let's compare again. We've got a 6 foot tall man and a 6 foot tall woman. Let's compare the man versus woman and their standard deviation. So data values minus the means divided by their standard deviation that we see in these tables. The z-score for the man turns out to be 0.7. The z-score for a woman, wow, that's definitely unusual. So for a woman to be 6 foot tall is unusual. And I like how we're going to end here with this graphic of from z-scores, like what's usual, what's unusual, and what's extremely unusual. And thank you for watching.